we try again to get our code to compile. Today we are doing another very fun LeetCode problem. Excuse me, hopefully we can solve it. Alright, so let's get started. Okay, let's see what we have today. We're working through the easy problem still, and this problem that we're solving today is called Subtree of Another Tree. Okay, so given the roots of two binary trees, root and subroot, return true if there is a subtree of root with the same structure and node values of subroot, and false otherwise. A subtree is a tree that consists of a node in tree and all of this node's descendants. The tree could also be considered a subtree of itself. Okay, so yeah, it's like this corner bit, or yeah, this bit. Because this one doesn't have all of the subtree roots, so it's not like enough to say it's like just inside of this one, but like it's not fully the same values all the way down. Okay, that's fascinating. Alright, so let's see what this is saying here in recommended time and space complexity. Recommended time complexity is O of n plus m. No, excuse me. O of n times, which means like looping through all the variables of n and m, and then O of excuse me, n plus n space, which is like storing all values of both of these in somewhere else, or like in memory. Okay. Where n and m are the number of nodes in root and subroot respectively. Okay, cool. This is striking me as being a lot like the other problem we recently did, which was same tree. I'm just going to take a look at that because I remember having a bit of a problem with calling the root nodes, if that makes sense. So, okay, here we just say P and that is the root node. Excuse me, and then this one did it like recursively. Okay, great. Just wanted to remind myself of that before getting too stuck into things and having some of the same problems we've already solved. So let's take a look then. A little look-see. So I guess one thing we could do is like first check through the items in root, like recurse through root, and see if those values match the values in subroot. Or like the root node, I guess, of the tree sub. Then, so let's write it down first. Sorry. First, let's look through the tree root to see if the root node matches the root node of subroot. Just to make sure that we're not getting in the way of the chat, let's put this on this other line here. Make sure I can see the chat as well. Great. Ooh, wow, okay. Yeah, definitely helpful there. Okay, then the next thing we'll do, check when the root nodes match, verify that the remainder of the root tree and the subroot tree match. Okay, so that sounds like what we're gonna do here. In terms of drawing a picture, it's essentially like isolating. So like we start at root, we go root.left, oh, root.left, subroot, like this item here matches this. So now that we have this and this, let's go to both of their root.lefts and see if they match. Now let's go to both of the root.rights and see if they match. So it's like two problems in one problem, which is pretty cool, I think. Okay, so first let's do step one. So like, okay, root is what we have. So let's do a while loop until we find this other value. So like because we're gonna say the answer is false unless proven true, so let answer equal false. and then at the end here, return answer, unless like something changes. So then while root is not equal to subroot, let's iterate through the items in root and until we get to subroot. So let's see. Let's do root dot left, or root equals root dot left, and then root equals root dot right. And then let's console log root all through here, because I'm not sure if I'm doing this properly, and console logs are a great way to see what's going on. So let's do that. Okay, so subroot's not defined, and that is because of the capitalization. They are doing a camel cased. I'm just gonna make sure that I match that all over the place. Great. All right. Now we should be good. Okay, cannot read properties of null reading right. Okay, and that is because we went left and then went right within the same operation, right? Yeah, okay. What would we like to do here? Would we like to iterate through in a queue? Yes, I think that makes a lot of sense. So like, let's use the queue like we're supposed to when we're doing a tree problem. So let queue equal, and then we're gonna put the root in the into this array called queue. Okay, so while we're not at the subroot, what should we do? We should enqueue the next values, or dequeue the first value, enqueue the next values, then go to the next value until the root that we're at matches the subroot, okay? So let's do that. So queue, or first of all, we have to have our current node, let current node equal, and then we're going to take the first item out of this queue, so that is shift, because all the rest of the items in the array have to shift forward. If we were putting something into the front of the array, it'd be unshift because all the other items will have to squeeze back. So right now we're going to do current items dot shift to pull out the first node. This is going to be a single equals. Okay, and then we're going to enqueue the next two nodes, so we have to do queue dot push, and then root dot left. Same thing again with the right node. Queue dot push, root dot right. The proper syntax here. Oh wait, no. Sorry, this isn't supposed to be root here. This is supposed to be current node. Oh, wait a minute, let's see. So yeah, definitely this is going to be current node. And this is going to be queue.shift, because we have to call something to pull something out of. Okay, I think at the beginning we can have a current node that's actually set outside of this function. And that'll let us put current node here, so that way we could actually be looking for it and comparing against it. So yeah. The other thing we could do is like we could have this be just an empty array and then have current node equal, or set current node down here. But then since we're unshifting to get our value, it would be easier if we kept root in here so that it's more consistent, it works the same for every single subproblem. That's what you want in a while loop, because it does the same thing again and again and again until something changes, right? So, okay, so what are we doing here? While current node is not equal subroot, and then let's say and queue dot length is bigger than 0, because like we want to be doing this as long as there is something in the queue for us to compare to. We want to do this all, but like, let's see, so if our current node, okay, sorry, I'm thinking in 3 different directions here, because let's write down the 3 things I would like to do. We would like to only enter right if there is a right, and that's in here like current node.right, current node.left. So same thing here, only enter left if there is a left. And then the third thing I'm wanting to do is like, if q.length is 0, like return answer. Because that means like that we didn't find it, we got all the way through the tree, done. So let's do those things right now. I'm just gonna do the alt-click method of adding things in 2 places at once. So if current node dot whatever, then we're gonna come in here and put the parentheses. Okay. And then here it's gonna be if there's a current node dot left, we'll put it into the queue, and if there's a current node dot right, we'll put it into the queue. And have our semicolon so that these if statements know that they are doing things. Great. And then if we find that like we are at the end of the queue and we have not gotten to something that matches the subroot, then we can okay, sorry, got a little distracted by another idea here. I was wondering, like, if we did hit the subroot, what should we do? I think that we should have another function within this function that checks the trees, like checks for same tree. Which would be really cool actually if we do it all in one function. So yeah, but then again, like we do here have like if while current node is not equal to subroot, so like if it breaks out of there, let's see. So I guess if it breaks out of there, then down here we would be in a position to do this if block I was talking about, where like if q.length is 0, which is like saying that we went through all the items in the first tree. So and like we checked it, we found that it's not equal, or like we never, excuse me, we never found the node that equaled subroot's node. So like if q.length equals 0, and that is to be in parentheses here, then we will return answer, which is that faulty statement we encountered earlier, or created, really, Boolean. Okay. Yeah, so we did that first step. Oops, don't want to do that, sorry. All right, so yeah, we did first look through the tree, the root tree to see if the root, oh, sorry, this was one statement. Wow, root node matches the root node of subroot, okay. So yeah, that's what we did all in this code. And then now if the queue's length is 0, that means we came out on this subcondition, or this condition here. And like if we did check through the full tree and we didn't find any node that matches the like base or root node of this tree, then we'd return false, which is the answer. Or actually, let's see. I wonder if root and subroot are both going to have nodes. So no, they could be equal to or less than equal to 0. So I guess if one of them is equal to 0 nodes and the other isn't, then they would automatically not be equal. So let's put that in here as like a base case. If that would be root or subroot. Let's see, if root equals null or subroot equals null or root equals null and subroot equals null. Well, I guess if both of them returned were if both of them were null, we would return true. So yeah, anyway, if root equals null and subroot equals null, or excuse me, okay, let's write that one down here too. So if they're both null, they equal each other. Fantastic. So if root equals null and subroot equals null, return true. Answer is false though, like for our default for everything else. So if root is null or subroot is null, so like one of the two is null, return false or answer. Okay, so now that we have those base cases out of the way, let's see where we were. So let's go back to our notes and see what we want to do here. So only enter right if there is a right, we did that. Only enter left if there is a left, we did that. We have the current node situation. We have figured out what happens if we come out of the while loop. Oop, what just happened? Okay, thank goodness for autosave. And also if you hit Alt and an arrow accidentally, it will take you back in Chrome. Who knew? Okay. Yeah, so q.length is 0. If that was our come out condition, then we are out here now. All right, and then now we're doing this bit here, which is, sorry. So yeah, when the root nodes match, verify the remainder of the root tree and the subroot tree match. So yeah, we're gonna do both these things, which is have another function within this function that checks for same tree. So yeah, it's like I wrote the same thing twice, so I just deleted one of them, and now let's do this function within a function to see if the same trees, like from that point, we have the same tree. So then the other thing I'd want to do is we have root and we have subroot. I'd want to like let another variable so that we can set the current node as the subroot. Actually, since current node is out here, and it's taken from q.shift, like whatever it is changed to from this q.shift, it would remain being current node. So current node would be from the root node and subroot would be from the subroot tree. So we already have a variable that is holding the current node of the root tree that is doing, or that has been rooted true if you want to use root multiple times in a sentence to make things extra confusing. But the tree that we're iterating from, that's called root, the node that we got to that is matching the node that is the base of subroot's tree would be held as current node, because in this function we are setting current node to this variable current node as like whichever node we're at that matches this here. So let's see. I guess what would happen though is like that we would have our current node. It would push its children into this, and then when it came back to the top, it would become like it would shift. It would have shifted, and then it would look. I'm not really sure how this is gonna work, but I'm really happy that we have this console log, so we'll find out. Let's just run it real quick and make sure we're compiling so far. Okay, so root is not defined. That means I typed it wrong somewhere else. this, which is kind of funny. Honestly, it's like anyone who has who's a developer should just automatically be able to put detail-oriented on their resume, because you have to solve so many little problems before things compile. But we are trying again dev, so we'll keep trying and trying and trying again until things do compile in the end. Okay, great. So yeah, we do. Ooh, love that for us. So we definitely returned false because we ran through or iterated through this second or this first tree we were given. Okay. I'm not exactly sure which nodes are left or right here, but oh, I see. So even if this were the subtree, interesting. 5 null null 6. Yeah, I'm not a billion% sure what's going on with this tree, but the fact that it hit one of the return false points is like good enough for me, honestly. But I do want to make sure that it wasn't this return false point that it hit, the return false. Okay, great. Fantastic. Cool. Okay, fantastic. Yeah. So that it hit this one, which means we are in order, baby. So awesome. Okay. So now what we want to do is pass in our current root node and the subtree node. So what I want to do that is instead of console logging every single operation, I want to make sure that the current node that comes out, maybe in this case where I'm expecting that 2, 4, 5 is like in this tree, where like this 3 is the left right node here and not a part of this subtree. Like I'm wanting to see that we get a console log of the current node that we're at, which should be the value or the tree node with the value of 2, aka where we are when we realize that this value is the same as this value. So let's try that. Okay. And we're not console logging anything, which is interesting. Oh, how interesting that we are. So it's returning false. That's interesting because I didn't notice that earlier. I'm wondering if oh, okay. Maybe let's do dot value for both of these so that we're making sure that we're checking the right thing here. Okay, here's why I'm confused. I think that this should eventually have current node being equal to this value, right? Because like this dot val and this dot val are 2 at some points. So what is happening? Also, I'm expecting that. Yeah, well, that's mostly what I'm expecting. So let's do some troubleshooting here. Let's try current node.val and compare that with subroot.val and find out why the while loop isn't breaking when they are equal to each other. It's like, here it is when they are. What is happening? I wonder if it thinks they're not equal because of the comparison or because they are in different trees or what. wonder if it's because it's like relying too much on this or something. Couldn't hurt to test it and see what happens. It's like, oh, that is still working. That's funny. Okay. Yeah, it runs around, it runs to where the queue's value is null, or like nothing gets pushed in and blah blah blah. This is so interesting. Essentially, in every case, it's not working. It's just going on and on and on and not recognizing that these two values are equal. So what I'm going to do is I'm going to write a note there, and then I'm going to come back to that after we write the second half of this problem. For some reason, the while loop is not stopping when the values are equal between you. Let me make sure it can be seen past the chat. When the values of the root nodes are equal. And then, as always, if you have any thoughts or would like to contribute, feel free to add your message to the chat, and I will duly try to take it into consideration. Okay. For now, though, we'll come back to this, and I'll bring it all the way over here to the left, so when I'm scrolling up, I know that I need to address that. In the meantime, I'm gonna create this function within the function called sameTree. So function sameTree, and then this is gonna take in 2 points. It's gonna take in, or 2 roots, I should say. Gonna take in the current node, which is the root, or the node of the root tree that matches the node of the subroot tree. Anyway, and then we're going to take in the tree subroot. And then in this function, what are we going to do? Okay, so first we have to decide what our base case is. The other thing we're going to have to do is write a recursive function. So recursive function depends on its base cases. Okay, but I'm just going to write base case for now and follow where my brain is leading me. So base cases with return true or false. And then what I'm wanting to do is call this function on the left nodes and the right nodes. So same, or this dot same tree of current node dot left and subroot dot left. And this, I'm just going to copy and paste this for the right sides. Okay. So let's see here. Similar to the other thing, we want these to be like if there's both a current node dot left and a current node dot right. So let's set that up. If current, I'm just gonna take these things and adjust this comment to the ands, because we definitely don't want to run this if there don't exist these things in these places. Let me check for my little note that I had here just to make sure I did an auto format and don't want my note to go away so that I can come back and fix it. But yeah, if the current node dot left and subroot tree dot left, then we want to run the same tree function on those items. Same thing for this function here, except we'll check that it has the right items. Okay, and then what do we want to say here? Okay. So if current node is not equal to subroot, return false. And somewhere down here we'd want to return same tree actually instead of this answer. Yeah, same tree of current node. Oops. And subroot. Okay, great. So yeah, so if current node is not equal to subroot, we'll return false. If both of them are null, which, I mean, I guess that shouldn't happen because that should be caught up here if the full nodes are null. And anyway, but we could have the case where we're iterating through and one of them are null. So I'll just have it. But yeah, if they're both null, subroot is null, we can return true. Yeah. Not sure if this is a Boolean or not. I think it shouldn't matter in JavaScript though. Not really sure at this moment. But we have some other cases to look for as well. Yeah, if these two values aren't equal, we return false. And okay, it looks like there's some issues with the stream, but hopefully they sort themselves out. Anyway, if current node equals null or subroot, for capitalization this time, equals null, we'll return false because that means that, you know, one of them is null and the other one isn't, so yeah. They wouldn't equal each other. So yeah, to fill out the sentence that I started like 3 times. Okay. So before we run this, and I'm curious to run it just to see if it compiles still. I know we still have to go back up and fix that one problem. Yeah, okay, great. So it's returning false before it even gets to the other function. So for this moment, I'm just gonna comment it out here. Right, okay, yeah, it should be lowercase. Awesome. I wonder though, before doing that, if it console logs anywhere else, or if we could get a console log going of anywhere else. So I'm like, let's console log the values down here. So that way we can get some insight into what is going on here and like why. Honestly, I would love to console log Q here and see what's going on. Because like, why is it hitting this false statement there? It's empty. How interesting. And this is sending back over the same root. Huh, why is that? So then here, let's see what our Q is. What is going on? Oh dear, okay. Yeah, so we put in 2. Oh gosh, okay, wow, there's a lot happening here. Okay, one thing at a time. Let's focus on just the console log of what's going on in the while loop. Okay, so 1 and 2. Okay, so current val, subroot val, q. So we have values 1, 2, and our q is the tree root fully with value 2 and value 3. Okay, now we move, so that's like the end of the while loop right there. If this, then this. Okay, so it's making me think that we should, instead of this being here, this should just have this case in here, and then like we should just put this other condition in here, and like as a break statement. So if like these values are equal, which, you know, it's fine if we push some values into this queue that we're just not going to use, that we like break this function, like break out of this while loop. So let's see what happens there now. Yay! Okay, great. So the two values are equal, with this value being current node, and we do break out of the queue, which is fantastic, exactly what we want to see. Okay. So if q.length is 0, now this return would work because yeah, we got through the queue, and also when we come out with a subtree, the queue is going to have the children of that node, so we wouldn't be equaling 0. So best of both worlds. Now, let's run the full thing and see what happens. Okay, still not working. Fine, fine. This is the console log from the beginning that we were just looking at, so we no longer need this at this moment. But I do want to just triple check that we're getting like values 2, 2, and the queue that has the children of 2, which are 4 and 5. So let's just look at that. Yeah, 3, 4, and 5. Great, that's the child of 1 as well. Fantastic. Okay, so it does mean that the right nodes of what I'm thinking of are going to be going into this function same tree, which is cool. And then now let's look at what all we're getting, what we're doing with these cases, and what we're returning that's causing the function to still break. So, okay, here. Oh, interesting. So wait, am I calling this on? Huh. Okay, so what I'm finding really interesting is here, the values of current node and subroot are root, which is interesting because I was thinking that this would be moving that all over the place, but it's not doing that. So maybe I need to have like this dot current node, because the having the let there was obviously making it another like variable, so it wasn't coming out of the function like I thought it would have been, which I must have missed in the last console log. But yeah, what I did was I added the this dot so that it would be like referring to the outer bit thing here. So okay, looks like I got an infinite loop. At least it did something. Hmm. Okay, I'm wondering how to get this current node out of this function without everything breaking. I'm thinking of going with the whole, like putting this as a function thing too. So let's just do that real quick. Function contains node, and then we'll pass in root, subroot, and then Q we don't need, current root we do need, the current node. But yeah, what we could do is let like subtree root equal this function call, passing in our two things. So that way, if something exists with that value, then we would have it. I mean, it would save here. But let's see. I guess we could return the two values or false. Return. I guess we'd only really need the current node because we would have the subtree or subroot from the like other problem. Yeah. Okay, if we wouldn't need this break statement, it would be taken care of with this return statement. So we would then call this function. Awesome. So then we'd be checking this subtree or this function same tree, calling that, passing in the subtree root and subroot. And then all these things that say current node are going to become or actually it could be current node over here, because here it is being called for what it's going to be called in the function, and here it's calling with what variable outside of the function we're using. So this is going to come into here. This is going to come, this is if the queue length is false, we would be returning false though. So this would come up into this function. Yeah, and then it would be after the queue.push items. Let's see. Oh boy, okay, I didn't even open this function. Gotta definitely do that. This would be here after the while loop, and this would be in this function, so it would be like here. Great. Just did a Alt-Shift-F to get our formatting back to how we were expecting it. Okay, we no longer need this current node outside of the function because we found out that we are checking it inside of this function only. So now to review our code, what we're doing is we're first looking at some base cases. We're having this queue that goes through the root nodes to see if any of them match the subroot node's root node. Sorry, this problem is a bit confusing for that. Then we're calling this function with the root node of the tree and the subroot root node of that tree. I'm going to take out this console log we're no longer using. If the root nodes match, we kind of exit this tree. This would be return false. So this answer could be false. And if it is, we should return false to the user. If not subroot tree, or subtree root, then we'd return false. Because it's like if this function tells us false, we need to return that. And then we have this function, the same tree, that checks this stuff, and yeah, if it finds the values to be the same, and that everything is null all the way through, it returns true. And if not, like if it finds things that are different, then it returns false. So let's try running this and see if we still get a Stack Overflow. Subtree root is not defined. Okay, what? Subtree root. At solution.isSubtree. Same tree, subtree root. It. Okay, well, let's see if it's coming out here by doing a console log. Okay, so I guess it's not coming out of here. This is supposed to be returning current node, though. Oh, maybe because it needs a let? Like, it needs to be defined? Yeah. Okay. Okay, one of the things we do here on this channel, realize that it's okay to ask for help. So like, what I'm gonna do is submit this code, even though I know it's wrong right now, and then that way I have a record of what I was doing, and we're gonna take a look at the solution to see what we're doing wrong, so that way we can adjust our code. Because what we don't want to do is like, excuse me, be going way down the wrong path and not like help ourselves. So that way, you know, we kind of ingrain this like negative pattern versus we want to be excited about trying these problems. So let's see how we should be able to do it to better be able to do it next time. Okay, so let's see what they do. Depth first search. Ooh, interesting. Serialization and pattern matching. Oh my goodness, wow. Okay, okay. Well, let's first look at this depth first search because that's kind of what we were trying to do. Okay, so if not subroot, return true. Oh, interesting, okay. So if you only have a tree, I guess null being a subroot of a tree somewhere is a true thing, sure. Sure, okay. Bum. So that's probably not doing what we needed to here. But yeah, if not root, return false. So if not subroot, return true. Yeah, if there is no such thing as subroot, if we only have a root tree, we want a true statement. Oh, I bet this is recursive. Oh, maybe not. Is subtree, yeah. Is subtree left, right, subroot. Oh, look at this. They put their other function outside of the main function. Wow, it's like double recursion. Oh my gosh. Okay, sure. So let's see if we can understand this code. Yeah, if there isn't a subroot, return true. If there isn't a root tree, but there is a subroot tree, return false. If this dot same tree of root and subroot return true, which is this other function, Otherwise, we're going to return this function of root.left and subroot, and this function of root.right and subroot. Okay, cool. So this is pretty much saying if we're going to search through the root tree until we find some value where the root nodes are equal, this dot same tree, yeah, okay, and then when they are equal, oh, they just do one check and use this other function to do the same tree check. Okay. Okay, so root, same tree of root and subroot, which they're doing in like a partner function because this is a solution, so you can do that. That's really, really clever. And then if not root and not subroot, return true. I think we did have that case correct. Yeah, except they did it more elegantly with the not instead of equals null, but that's beautiful. All right. If not, if root and subroot and root.val and subroot.val, wait, if root and subroot, okay, so if both of these points exist and both of the values exist and are the same, then we return, okay, then we go ahead and search down in those trees, and if not, we return false. Okay, cool. Well, we tried. Today we didn't get it, but tomorrow we're going to try this problem again. So thank you so much for joining here at Try Again Dev, and we'll try again tomorrow and hope we have some better luck next time after giving ourselves and our brains the fodder it needs to try this problem tomorrow and hopefully succeed. Hope you're well, and have a great day. Good luck with your code solving. Bye.